All right, hello again, everyone. Um, Here is my newest project. Don't mind everything that's happening over here. Not related. What we're focusing on is the right side of my breadboards over here. So what is happening is I have this fan right here and a temperature and humidity module, a diode, and right here, this little guy is a NPN transmitter. So what's happening is I wanted this to measure the temperature, say in a room or anything, and then once it reaches a specific temperature, the fan will turn on, cooling off the area. Kind of like a more simplified AC unit, that type of situation. So as you can see here, we got code that's going on right here, and what the serial monitor is telling us is the temperature and the humidity that the module is sensing. So I have it on 25 Celsius. So once, as it says here, once the temperature is greater than 25 degrees Celsius, the fan will turn on. So right now, as you can see, it is at 31.10 degrees Celsius. That is because I just turned I was able to get the fan to work. But I can easily get it to do it. Shamefully, I'm breathing on it. Yeah, I know. It's a whole thing. But it works. It makes it harder. So give me a second as I breathe on this. It is the only thing that I can figure out to actually increase the heat. So as you can see here, the humidity is going up tremendously. So I think once it gets to, so as the humidity increases, so will the temperature. Oh, okay, we're almost there. All right, where are we at? 40. Oh my gosh, we're almost there. I really hope I don't pass out doing this. Oh my gosh, we're like so dang close. 70, 80. Should start. Okay. Come on. Oh dear. Okay, so it stopped at 25. And now it's going down again. I'm really gonna pass out doing this. Come on. Aha. There you go. Now it is on. As you can see here, it was getting a lot harder. It went above 25 degrees Celsius. So now with this fan, it's gonna be start blowing on the temperature thing. Aha! See, it turned off because it is now below 25 degrees Celsius. Isn't that cool? Now, this was definitely a challenge to build because, I mean, so far I haven't actually dealt with through these classes. I'm getting more and more I guess you could say advanced in the things that I'm doing, because like right now I've made a few videos on it. I've used the ultrasonic distance sensor because I thought it was like super cool. Still think it's cool. I used the stepper motor right here. I of course, use LEDs. That's simple. But and the photon right here, um, another cool project because it actually connects to the Wi-Fi. But which you can see in other videos. But I don't know. I never used the temperature module. I never had to use a diode or a NPN. I haven't even used the stepper motors. I mean, sorry, not a stepper, DC motor. Um, Now I have used them in Tinkercad, but Tinkercad, I didn't really get to gain much from it due to Tinkercad is good for practice when you're like for beginners. Great to start off in, but once you get more and more advanced, it the um, the simulation it doesn't simulate things very well because like I have a whole program for a DC motor, but it didn't really translate that well. It didn't work the way I needed to. Actually, you can see this in another project because I made a analog sensor. Actually, I believe I used that with the photon. Um, and hold on, oh sorry. With the photon, I used the analog sensor and it like made the lights go back and forth. Um, no. Sorry. That is the Larson scanner video. Very sorry. But yeah, and it just the lights went back and forth. Really simple. But I remember struggling a lot with the Tinkercad on that. And then of course there's the video where I use this. That is the analog sensor, and based on the distance that the ultrasonic distance sensor is sensing, the light will go show the distance. This is closest, this is farthest. So yeah, Tinkercad isn't very well. It doesn't do well, so I didn't really get to understand how DC motors worked fully. But now I finally got a chance to. So yeah, and I didn't know that a lot of the time you would need um, the diode and the NPN. Well, actually, so interestingly enough, I didn't see much with the diode until I had to research more, and I'm not sure why originally I only saw ones with the transmitter, but not the diode. But once I included the diode, I finally got things to work. Because originally, what happened is, so we have the what is this? So we got collector. So if you can see well, as you can see, the flat side is facing us. So when the flat side is facing us, we have the collector, which would be the very right, the base, which is the middle, and E is 1 second. Emitter. E means emitter. So how I originally had it, I was told to put the power supply for the motor into the collector and the negative into the emitter, and nothing was happening. I wasn't sure if the code was wrong, but something told me to try and figure out if I wired this wrong, because I could have spent hours trying to fix the code and get nowhere, while I probably just didn't understand what it was asking me to do when wiring this motor. So, because everything was reading correctly, like the temperature and everything was reading correctly, but nothing was happening with the motor. Even when I changed the temperature. And then what ended up happening is, since the power supply was in the collector, I ended up putting a wire from here to the power supply. That's probably not a good idea to put that near a electrical part. Anyway, when I put a wire here and here, the fan turned on, but it wasn't prompted to. And I realized immediately that the reason why I turned on is because it was getting a power supply. So it was pretty much bypassing the command and just getting power, turning on. I could actually probably show that here. I'm gonna unplug this. Plug this here. All right, actually, probably because of the diode. Okay, buddy. Hold on. There you go. As you can see, even though I actually had this power supply in the power, nothing happened because of the diode. But clearly here, nothing is occurring that would actually make it do that. It didn't reach 25 degrees Celsius or anything. It just has a power supply now. So I'm just gonna try my best to put you down. Okay. Chill out, buddy. You know, I wish I had a third hand. It would make my life easier. Okay, screw it. You're going there. Okay, there you go. There you go. Okay, we're good now. We are good. Sorry about that. All right. Good, you stay there. All right, but yeah, that's pretty much it. My next video, the reason why this is here, why you've probably seen this in so many past videos, is because this is a final project for something, for a different class, and what I'm trying to do is have a ultrasonic distance sensor sense the distance from an object, and then it's going to tell a stepper motor, gosh dang it, not a stepper motor, a servo motor, how much it should move based on how close an object is. You've actually seen that in a past or in previous video, actually probably yesterday, as of recording this, but pretty much it was how that would work. But what's going to happen is through the distance, this is going to move. The servo is going to move, and I'm going to have that servo motor placed right over this, or should I say the blade, I guess it would be over my photoresistor, and it's going to cover the photoresistor, so there's no light. And then when there's no light, these lights will turn on. But say the servo motor moves away from it, light will most likely hit it and the lights will dim. Now, this is important because it's going to be kind of like a complicated nightlight. So how it's most likely going to work is the closer an object gets, the closer the servo motor will move closer to the photoresistor. I think that is how I'm going to do it. But yeah, so that is what's going to be going on. So that'll most likely be the next video unless I have to build something else. But yeah, you guys have a good one, and let's hope this project goes well. All right, bye.